So let's practice this new principle on a few problems that use the weight of an unknown amount. Because we don't know the amount of its weight, we can't put a number on it, so we will use a letter to represent its weight. This letter acts like a placeholder until we can figure out its weight using algebra. Let's start with the following situation on our scales. On the left side, we have a 5-unit weight and a new object whose weight is unknown. Because we do not know the value of that weight, we will mark it with a letter instead of a number. In algebra, we use letters such as X, Y, Z, or A, B, C, etc. to represent the unknown values of things. Like I said, it has a definite value, we just don't know what it is yet. Actually, finding that value is the problem we want to solve. In fact, do you enjoy mysteries? Because as it turns out, algebra works very much like a mystery. With it comes a set of tools that you use, much like a detective, to solve the problem at hand. In this case, we're trying to solve the secret number hidden behind the letter in order to discover its unknown weight. Now, I could choose any letter I want to represent the unknown value of its weight, so I choose to use X as a temporary placeholder or marker. Looking to the right side of the scales over here, we have a 2-unit weight and a 3-unit weight and a 4-unit weight. Remember, the problem we want to solve is, what is the value of the unknown weight? In other words, how can we use the fundamental principle of algebra, which we just learned, to solve for the mystery of what weight the X represents? That principle says that if we start with an equation, we can keep both sides equal as long as whatever we do to one side of the equation, we do the exact same thing to the other side. So, looking at the picture, what algebraic equation represents this situation? Go ahead and take a moment and write this out on a piece of paper, and I will wait a few seconds so you can think through it before I give you the answer. Okay, let's take a look. It is 5 plus x equals 2 plus 3 plus 4. Now notice what happens if we subtract 5 from both sides of the equation. On the left side, we take away 5, and we end up with just x. On the right side, we also have to take away 5, so we'll still have an equation. We know that 2 plus 3 equals 5, so we take away the 2 and the 3. That leaves just the 4 on the right side. We now have an equation that says x equals 4. That means we've just solved our problem by figuring out what x is. So now we know that the new object weighs 4 units. See, it was actually a 4-unit weight all the time, we just didn't know it until we solved the mystery using algebra. Now we want you to try one of these. Consider the following situation. On the left side, we have an object of unknown weight, which we will mark with an x, and we also have a 2-unit weight on this side next to the x, so we write x plus 2. On the right side, we have a 2-unit weight and a 6-unit weight, so we write 2 plus 6. And the scales are balanced, so we put an equal sign between the two sides to show that both sides weigh the same, they're equal. Here's the question we have to answer if we're going to solve this mystery. How do we get x by itself so we can find its value? Yes, we must take away something from the side with x. What is it that we need to subtract? Remember, if we do one thing to one side, we need to do it to both. What number do we need to subtract from both sides of the equation so we end up with just one x on the left side and only a number on the right side?